everybody. Today we will talk about machine learning algorithms and SVM, support vector machines. And we did logistic regression and KNN, nearest neighbors classification. And we our accuracy score is 0.94 in classification. And interesting, very interesting, the KNN is the same, 0.94, and we wonder the SVM accuracy score. Firstly, I want to talk about SVM, support vector machines, the name, and this green area is margin, and this stick is the optimal. It must be optimal if we productive productive model, if we want to productive model, and this line is the optimal line. For example, this line can be this and that, but the optimal is that this. If margin is large, that's good. This is the linear SVM, linear kernel SVM, and this is the RBF kernel, and this is more better. This is better than the other. Now we can start and importing the libraries. Import pandas SVD. Yes. Import to dataset. Our dataset is the same, and cancer dataset about the class is um, malignant or not, tumor, bad or good, 2 and 4, and this is the information about the cell methods or uniformity of cell shape, yeah, size, yeah, and we don't use this column. And import the dataset equals and pd dot read csv data dot csv, and I like to copy that dataset dot copy, and we can look our dataset tree index. Now we don't use this column. This is class R targets column. This is features, our features, and x equals df dot ilog all indexes and 1 to 1 to minus 1 without last column dot values. What's the meaning of this? Is all indexes meaning, and this is to start one column number 1. This is 0, and we don't take this column, and column 1 we take this, we start this, and 2 methods without class. Yes, and y df.ilog the same, all indexes, and just only the last column and values. Yes, right. We can split train and test sets, and from scikit-learn that model selection import train test split function. Yes, x test, x train, x test, y train, and y test equals, we can use train test split function and our features and target and test size the same, the previous algorithms. Test size equals 0.25 and random state the same, the previous algorithms is 0. KNN same, logistic regression the same, and we split it train and test set. Now with feature scaling is improving our model, so we can do that. And from scikit-learn dot pre processing imports standard scaler, we can make object standard scaler. From standard scaler we don't use any parameter, and x train equals standard scale dot fit transform method. We can use x train, we can transform this train set and copy that x test, assign that. Very good. And uh, um, processing, yes, very good. We can do model from scikit-learn dot svm imports svc, and we can make a model SVM classification shortly, and SVC we use some parameter, for example kernel, our kernel, firstly RBF, we use RBF, and this is RBF, we use this RBF kernel, and random state equals 0, and we can fit our train and x train and y train. SVM classification dot fit x train and y train. Very good. Our model had done, and we can predict our test model. Ypred equals svm dot classification dot predict method. We can use this method, and which x tests and predicts, sorry, predict. Very good. And now it's very good performance place, and accuracy score, we will use accuracy score and confusion metrics. Let's start from scikit-learn dot metrics. We use metrics import accuracy score function and confusion metrics function. Very good. We can print that. Oh, sorry. We can print accuracy score is firstly we use the real targets y test and our predict targets y pred, and we can copy this, we can paste, and confusion metrics, copy and paste. Yeah, at firstly we can use again our accuracy score KNN 0.94 and the same logistic regression 0.94. I'm really wonder that's our accuracy score SVM RBF. And now, oh, the same accuracy score we have 0.94. Very interesting. And I really wonder the RBF is accuracy score. RBF has accuracy score 0.94. And what about the kernel is linear? We can do that. And SVM linear, for example, SVC and kernel equals linear. For example, random states and same, and we can fits our linear dot fits x train and y train. Very good. And again we can predict and SVM dot linear dot predict x test. Very good. And we can copy this and paste without this. And if the linear accuracy score uh, accuracy score is lower than the RBF, linear is lower than the RBF. RBF is more power than the linear. Linear accuracy score is 0.949415. The RBF accuracy score is 0.947. Now let's finish and have a good day. See you again.